Good morning, mathematicians. New day, new episode. Who knows what random nonsense we'll discuss today? Good morning, mathematicians. Possibly my research. Possibly archive. Good morning, Yaman. Good morning. It's quiz day today for my students, for my discrete math students. I wonder how they'll be doing. Thankfully, I don't have to grade this one at all because I had a friend of mine I had to cover for a friend of mine, so I had to grade all of quiz 2, but that means he's gonna grade all of quiz 3. So freedom. Yeah, big news in the math world, I guess. Teaching summer classes, yeah. Well, TAing. I'm just TAing right now, but yeah. I don't know if you guys saw this article about a 17-year-old proving a crazy conjecture in harmonic analysis. Wild stuff. There was a really nice picture. Yeah, look at these nice. I wonder if she has a talk online, because yeah, I saw these notes. These notes look really nice. Yeah. And also, this is interesting that Springer publishes P equals NP. I wonder if this is just a journal that's like a subsidiary or something. Yeah, I'm interested to see how this happened. I wonder if someone in the comments knows. Oh, there's a talk on her YouTube channel? Oh, I didn't know. Sweet. Okay, cool. Might have to take a look at that. Oh, one of the authors is a deputy editor-in-chief of the P equals NP paper, or P not equals NP paper. Wild. It's crazy. Man, I don't know why I'm so tired right now. I gotta get that coffee in me. I thought I had a decent night's sleep, but my eyes, they're heavy. Wait, what? What do the comments say? Linguistics degree. What? Why? No. Yeah, interesting. I want somewhere here to be someone that's in the know. Something like that. It's not a junk journal. Interesting. Yeah, because that was my immediate thing. I think I maybe even did I go check its no, the other day we looked at a There was something we were looking at the other day. There was some publication. We looked at the impact factor of some journal. Maybe that was the algebraic topology dispute that we were diving into. One of the authors is an editor for the journal, according to this comment, as you said, Ken. Declared call, I don't know what that is, and recused from editorial decisions. It's so funny. It's so funny. So many people have keep posting this same page from Scott Aronson, which is great. It is a great page, but like, I don't know. It's just funny how many people reply. Oh, conflict of interest. Oh, COI. I see COI. I see COI. Yeah, it's funny. I don't know. People on Reddit, they just all want to give their answer, you know? And not that I've ever given not that I've never given a stupid answer myself or something, right? But it's like, well, you spend 2 seconds looking to see what people have already said, you know? I'm sure I've complained about this before, but the thing that drives me the nuts the most is when, like, you know, there's like several paragraph thought out answers, you know, and the timestamp on them is from like 3 hours ago, and then you'll see like a 2-sentence reply from like 20 minutes ago, and it's like, why did you bother giving your shitty 2 sentences that contributes absolutely nothing? It's human nature. Yeah, I mean, I guess. Like I said, I'm not exactly innocent of such things, but like, it's funny. It's even funnier when there's like, okay, it's one thing for them to give a shitty comment, but then it's also like, and it's totally fine if they're all within, you know, a couple minutes, right, of each other. Then it's like, yeah, they probably didn't even see the other comments. They're just like, I'm gonna reply, so hey, whatever. Some people leave more verbose comments than others, whatever. But it's like when people admit in their comments too, they're like, well, I don't know what I'm talking about, but or like, I'm not an expert, but, and then you see those juxtaposed to like well thought out correct answers from like hours before. I don't know. Even the abstract sounds contradictory. And later published an opposite result? No way. No way. No way. Wow, the whole dish of crackpots we could get into. The Boosman-Petty problem, posed in 1956, has an interesting history. It asks, if we have two origin-symmetric convex bodies, such that the volume of each central hyperplane section of K is less than the volume of the corresponding section of L, does it follow that the volume of K is less than the volume of L? Gut reaction must be yes, and by Minkowski's uniqueness theorem provides some justification. Implies that an origin symmetric star body is completely determined by volumes of central hyperplane sections. Okay. Nevertheless, in 1975, everyone was caught off guard when Larman and Rogers produced a counterexample showing that the assertion is false in more than 12 dimensions. The counterexample is quite complicated, but in 1986, Keith Ball proved that the maximum hyperplane section of the unit cube is that, regardless of dimension. But in 1992, only 3 and 4 dimensional cases of these remained unsolved, since the problem is trivially true in 2 dimensions. And by that point, counterexamples had been found for all n greater than or equal to 5. Intersection body proved. Maybe I should make one of my videos on those instances of crackpottery in math. Maybe. I don't know if I want to invite more attention from crackpots to this channel, but it would be good for engagement. Drive up some views if I don't know, made some videos like taking down crackpot theories. Ooh. Maybe I could go. I feel so stupid for doing this. But I went to, where was it? Our Colat. I did spend some time here. So stupid. I most likely all of these people cannot be reached. But I did spend some time. So someone, my paper is correct and I need help. I found a bunch of things just at a quick reading. I pointed out to them, but it still takes a little bit of time to glance it over and write up these comments. Okay, some of these things are minor, right? Like them saying adic instead of p-adic, although you should kind of specify the p, because they were claiming that something's a p-adic number. Well, which p? But yeah, then they definitely said things that don't make sense, like talking about the dimension of a measure and whatnot. So, there's some other back and forth from this, so we'll see how they do. But then, I don't know. I mean, this is a crazy comment. I mean, it's not wrong, I guess, in a certain extent, right? All you can really do. I mean, there is a part of me that's an extreme skeptic, and that's what I like about mathematics, because it's like, well, it just comes down to my understanding or not. But like, well, then what's the whole point of peer review? Yeah, well, why even publish? Anywho, that wasn't the point of this, but yeah. I was getting back to here. Okay, in '94. Zhang published a paper in the Annals which claimed to prove that the unit cube is not an intersection body, and then the problem has a negative answer and n equals 4. For 3 years, everyone thought it had been solved, but then in '97, provided a different approach, Fourier analytic. His new characterization showed that the unit cube is an intersection body. Okay, now I'm a little disappointed because we sat here, we did all of this reading, and this person's comment where we got here from, I was led to believe that it was the same author. Uh, where was it? A guy published a result, and later, okay, the way that this person said this made it seem like it was the same person who published the result later published the opposite, and that doesn't seem like that so far. Oh wait, maybe the next paragraph. Okay, maybe this person will be vindicated. Turned out Zhang was incorrect, and this reopened it. After learning, oh gosh. After learning that the result contradicts his claims, Zhang quickly proved the fact. Okay. Good recovery. Opposite of what he previously claimed. Also published in the Annals. Wow. Good story. Okay. Good story. And that's why you guys come to office hours. For content you could have got on Reddit. Actually, that's not true. Why do you come to office hours? You guys haven't been asking questions lately. Mind you, I guess I neglected to solve Matthias's what was it called? Bernoulli inequality. I didn't feel like hashing through it though, because it was all on Wikipedia. I could go back to yapping about my D modules again. Yeah. Where were we here? Oh yeah, we were talking about Chomp yesterday. What to talk about today, though? What sort of random math? Actually, I might end the stream early. I'll probably end it at like 9, in like 9 minutes. But until then, what are some random things we could yak about? Will Day is officially able to pursue your Ph.D. Hell yeah. You're going to study operator algebras and representation theory in mathematical physics. Nice. Congratulations. When are you starting? I mean, it sounds like you just found out. So are you starting in the fall? That seems like a short gap between finding out and starting. Or are you starting in the winter? Arad would take some D modules talk. Well then. Hell then. What have we, where were we in all of our D modules discussion before? Did we carry out a computation of the Riemann-Hilbert correspondence? I think we started doing that. No? I think we did fully carry it out. So I guess there's another thing that I'd like to talk about. Spring opting in. Okay, nice. So one thing I want to talk about in the theory of D modules that's important for my research group is so the D modules, right? So we've got our variety or manifold X, and we've got our category of D modules on it. And well, one should possibly expect some relation to the tangent bundle or the cotangent bundle. Why is that? Well, if we think about it, the D module, right, is generated. So let's think about the D module for affine space, for example. the global sections. I'll just write C to the n, right? The global sections of this thing. This is the, generated by x1 to xn, and then we stick on the little del's as well, right? And then subject to our relations. So the thing is, the del's can be interpreted as like coordinates in really the cotangent bundle. Isn't the cotangent bundle contained in the sheaf of differential operators as the degree 1 part? Well, depends on what you mean by the cotangent bundle. I mean, when I think about the cotangent bundle, I think about the differential geometry perspective as some space. So it wouldn't be contained in the sheaf of differential operators. But yes, yes, I get what you mean. Yes, exactly. Yeah, basically the right, our other way to talk about, the D module is that it's the sheaf generated by the sections generated by the structure sheaf and the sheaf of differentials, and somehow the sheaf of differentials, this is like the structure sheaf of like the fiber over a point, basically. And so actually we can take this idea quite literally. So it turns out what's a good way to say this? Well, I don't want to give improper definitions, so I won't give the full fancy definition today. But one of the things that we need here is I'll give an example in the easy case. So remember that we had these D modules that were basically defined as the left ideal generated by some differential equation, right? So in previous office hours, we investigated what was it? So we had the differential equation generated by x. We had the differential equation generated by del, and we looked at the differential equation generated by del minus 1/2. I believe these were our three sort of D modules we looked at. And so there's a much more general way to do this for an arbitrary D module, but in order to not say something wrong, I should probably pull up the actual definition before we talk about that. But there is a special subvariety of the cotangent bundle that can be associated to each one of these things. And in this case, we form what's called the principal symbol, which, by the way, has, I don't totally understand it, but there's also like the notion of a principal symbol comes up in the I think I said the differential equation wrong. I think we wanted this should have been x del minus 1/2. Yeah. And so this also gets studied just in the general theory of like differential equations and stuff. And so one of the things with the current collaboration that our group has going on is, we want to better understand the differential equations perspective on this stuff, and something called wavefront sets. But so the principal symbol for any one of these equations, well, our differential equation, using the commutator rules, we can always, alpha here is going to be a multi-index. So there's some, AIs, we have some coefficients here. right? And this is just some sum. And let's say k is like the largest degree of any operator. So the degree is, you sum up all the powers of x and the powers of the dels. You know about symbols from elliptic theory stuff and Hodge stuff. Yeah, so somehow this should be the same thing. This should relate to that as well. And then the principal symbol is basically what you do is you chop off all the lower terms. So you just look at the highest degree terms, and you keep your x's as x's, and you turn your dels into x's, or let's call them y's. And then the characteristic, so sometimes it's called the singular support, and we can talk about why, or the characteristic variety of the D module. And again, this does have a more general definition. This is going to be a subvariety of the cotangent space where basically you give it coordinates where the x corresponds to the x part of this, and the y corresponds to like your coordinates of one forms, and it's basically just the zero set. So it's basically just the zero set of the polynomial. So all x and y, which makes this polynomial vanish. Yes, there is a coordinate free. So that we need to, in order to do that, yeah. So there's a little more background and baggage to describe the general thing, because basically why it's called the singular support in some sense. Well, I don't really know why the singular word is there exactly, but why it's called the support is because, hello black, is because in the general definition, you basically, you can take your D module, you can take an arbitrary D module M, and then you can take, you look at the graded version. So basically you consider you break it up into the grading. We have this filtration by degree, and we take the direct sum of sort of each of the degrees, and now this becomes, and we take like the graded D module here. Well, the graded D module ends up, now this becomes commutative. Because of the way that we chop up the grading. And this should be isomorphic, I believe, to the structure sheaf of the tangent bundle once you take this grading. So therefore, the D module structure on here, in fact, induces an O T star X module on here. And then we can define the characteristic variety, or again, the singular support, as it's sometimes called, as just being the support of this as a sheaf on Tx. And so this will be a subset of T star X. So that's the like coordinate free description. Yeah. So for these D modules above, right? Well, what's our picture? So our principal symbols, we'll call it sigma 1, sigma 2, sigma 3. So we basically have, I'll write them again down here. We basically have three equations. So sigma 1, sigma 2, sigma 3. This is basically the equation x equals 0. This is the equation y equals 0. And the other one is xy equals 0. And so in this case, right, our variety is just the complex numbers, and so our cotangent space is just the complex C2. So, okay, drawing, a bit abusively, we find that, right, so x equals 0, this is the variety carved out by sigma 1. This y equals 0 is the variety carved out by sigma 2, and then the variety carved out by sigma 3 is going to be the union of these two things. Okay, so this all means something interesting geometrically. But remember, in the back of our minds, this is all supposed to mean something for groups, for p-adic groups, representation theory, right? So these D modules slash perverse sheaves and their behavior was supposed to tell something about multiplicities of representations. So, one might wonder then what are these singular supports supposed to mean for our representation theory? And that we'll come back to next time, because I'm gonna cut it off here and get a little bit of work done before I have to go hand out some quizzes and make my students miserable. So that's a very brief introduction to singular support stuff. Enjoy. Go prove some things. I'll go prove some things. And I keep telling you guys, we'll meet back here tomorrow to discuss the things that we proved, but you guys haven't told me enough about what you've been proving. So tomorrow,